All right, let's dive right into the invisible world of chemical reactions. I mean, this is the stuff that explains everything, right? From a brilliant flash of light to the very food that ends up on our plate. So, yeah, let's get started.
So for this journey, we're going to get our inspiration from a fantastic classroom primer, where teacher, Dr. Shubham, just makes chemistry come alive. Let's imagine we're stepping right into his classroom to see all these reactions through his students' eyes.
First up, we're going to explore the two most fundamental actions in all of chemistry: combination and decomposition. You can really think of it as the basic toolkit for, building up and breaking down the world all around us. Let's see how it works.
So, Dr. Shubham starts with a classic experiment. Picture this. He's holding a simple, thin strip of magnesium ribbon. He lights it. What do you think happens next?
It is a pretty spectacular sight. I mean, a blinding white light, almost like an old-school camera flash. And what's left behind? It's not a metal ribbon anymore, just a simple white powder. A complete transformation has happened. So what do we call this?
Well, that was a combination reaction. The magnesium literally combined with oxygen from the air to create something totally new, magnesium oxide. So in short, two different things came together to become one single thing.
And Dr. Shubham has a great way of thinking about this. Just imagine individual players, A and B, and they join forces to create one strong team, AB. It's a really simple and memorable way to get the concept.
Okay, so we've just seen how to build something up. Now let's do the exact opposite. Let's take something apart. What do you think happens when we take a single substance like limestone and just add heat?
The result is pretty fascinating. The solid limestone, it just breaks down and it releases a gas. And we know it's a new gas because it has this really distinct property. It can actually put out a flame. This tells us the original substance has been completely broken apart.
And yep, this is called a decomposition reaction. It is the perfect inverse of what we saw before. One complex compound breaks down into two or even more simpler products. So one thing becomes many. The analogy for this one is perfect for our everyday lives. When you're facing a huge project, what do? You decompose it, right? You break it down into smaller, easier tasks. Turns out chemistry uses the exact same logic.
All right, so we've covered making and breaking. Now things are going to get a little more dynamic. Let's take a look at what happens when elements decide they want to swap places.
Okay, here's the next classroom setup. We've got a bright blue solution of copper sulfate, and right into it goes a plain old iron nail. Any guesses on what we're about to see?
The result is a total makeover. Seriously, the iron nail is now coated in this reddish-brown layer of copper, and that vibrant blue solution, it's lost its color. A chemical swap has definitely taken place here.
Dr. Shubham's analogy here is just perfect. This is a displacement reaction. The more reactive element, the iron, it literally displaces or kicks out the less reactive copper from the solution. The stronger player just takes the field.
But what if everyone wants to switch things up? Well, that leads us to something called a double displacement reaction. Instead of just one element pushing another one out, here we have two compounds that completely exchange their partners. It's almost like two couples swapping dance partners to create two entirely new couples.
Next up, we're looking at a process that happens absolutely everywhere around us, and even inside our own bodies. It's this fundamental give and take that powers so much of our world.
So this process is called redox, and it's got two parts that always happen together. You can think about it as the transfer of oxygen. In the simplest terms, oxidation is the gain of oxygen, while reduction is the loss of oxygen. And here's the key. You just can't have one without the other. At its heart, it's really just a simple transfer. One substance gives up oxygen, and another one takes it. That's a redox reaction. And this simple exchange powers everything from the rusting of iron to the batteries in our phones and even the metabolism that keeps us alive.
Okay, now let's bring all this chemistry home, like right into our own kitchens. How do these reactions affect the food we eat every single day?
Come on, we've all experienced this, right? You open a bag of chips a week later, and that crisp, fresh taste is just gone. Or you smell cooking oil that's been sitting out, and it just smells off. So what's going on there?
The culprit is a chemical process called rancidity. And hey, look at that keyword right there, oxidation. It's the very same process we were just talking about. The fats and oils in our food are actually reacting with the oxygen in the air.
And it's a simple, pretty destructive chain of events. So, step one, food gets exposed to oxygen.
Step 2, those fats and oils oxidize. And Step 3, that chemical change creates new compounds that have that really unpleasant smell and taste.
But now that we understand the chemistry, we can fight back. Airtight containers, they limit oxygen exposure. And those antioxidants you see on food labels, they're added to literally stop that oxidation process before it can even start. See, it's all just practical chemistry.
You know, this really gets to the main takeaway. From baking a cake to a battery powering your phone, chemistry isn't just stuck in some lab. It's the engine running our everyday lives. So, the real question is, now that you know the basics, what other chemical reactions are you going to start to notice? Thanks for tuning in.